Hello, everybody. I hope you're all doing well and you're ready for more of our Alberta math contest. We're looking at question 4 now on the multiple choice part of the competition. Some n greater than or equal to 3, so some n different positive real numbers are arranged on a circle such that each number is equal to the product of its two neighbors. The value of n is... Okay, so we've got more than 3. We've got positive real numbers are arranged in a circle, and here are our options: 4, 5, 6, 8. None of these. And each number is equal to the product of its two neighbors. Okay, this is interesting. It's kind of sort of a logic-y question. So I know I need at least 3 numbers. And they said different, right? Different positive numbers. Okay. So let's imagine a circle. Now, they're not particularly specific, so let's make one of our numbers 1 and the other one 2. Well, no, actually, we can't have 1, because then 2 would have to be something times 1, so let's say 2 and 3. Okay. So 3 times, so 2 would be 3 times what? Well, 2/3. 2/3 would be 2 times what? 1/3. So we can just sort of work around, and hopefully we should get back to 3 at some point. Okay. 1/3 is 2/3 times a half. A half is 1/3 times 3 halves. And 3 halves is a half times 3. So we've come full circle, and 3 is 2 times 3 halves. So we've got 1, 2, 3, 4, 5, 6 numbers. Okay. So our answer should be 6. We just sort of needed to experiment. I find this happens a lot, especially with some of my university students. They read a question and they say, well, I didn't see an automatic way to do it. Like, you never taught us how to do a question exactly like this, so I just gave up. And no, we just, I had no idea what the numbers were. I just sort of played around with it. Now, we could say, well, what if there were other numbers? Now, you'll notice, unlike question number 2, we don't say there wasn't this, what was it? Not uniquely determined. None of these is different from not uniquely determined. So because we've got 6 and we know there's only going to be one right answer, we can just go ahead and say, all right, the answer is C, and we're done. Right? And we don't need to try for 8 or 5. But suppose we wanted to make sure we didn't get lucky. Let's just pick 2 random numbers, x and y. How do you make y, x times what is equal to y? Well, y over x. And then you'd have to have 1 over x, and we just sort of assume that these are all different numbers. If they weren't, you could get kind of lucky. I think, if you did 1, 2, 2. But then you don't have different numbers. Anyway, and then you'd have to have 1 over y times y over x is equal to 1 over x, so that's the number in the middle. And then we'd need to have what? X over y, and then x over y times x gives me my... x over y times y gives me my x, so we know there's nothing in between here, and so we get 6 numbers no matter what. I think there was a recent Euclid contest question that had to deal with this. It might not have been 2017, 2018. It might have been like a 2016 paper or something like that. Or maybe a 2019. But I feel like there was a Euclid I've gone through recently that had a question like this. But there we go. We get our answer of C, and that's all there is to it. Okay. So, yeah. I don't really think there's anything else I want to say. This is an unusual question. You really just sort of have to jump into it. So I started by picking 2 numbers. Why didn't you pick an X, Y, and a Z? Why didn't you pick... Well, because as soon as I know I have 2 numbers side by side, I can figure out the next number, and the next number, and the next number, because they tell me this nice relationship. Each number is the product of its 2 neighbors. So as soon as I've got one number on one side, I can figure out what the next number on the other side of my current number should be. Okay? So there we go. And up next, of course, question number 5. I'll see you then.